continue incrementing through the frames that are already stored, in stream mode, it will always point to whatever's being sent to the microprocessor. Aside from that, the programming of the LED drivers takes place through the SPI controller on board the microprocessor. So in summary, to develop our software, we used C and Code Warrior for the firmware and Visual Studio 2008 C# for the GUIs. The GUIs are also written on top of the .NET 3.5 framework for ease of making Windows forms. Our software is successful. We can program all of the LEDs. We have a fast image transfer speed well above our requirements, and we can achieve 30 frames per second animation rate at a refresh rate of 60 Hz, which means that we're rastering through every column at 60 Hz, but we're changing every frame at 30 Hz. These are, to recap, our actual engineering requirements. We are under the max dimensions of the unit. We are powered by US wall socket. We can control the LEDs and they are spaced correctly, and the refresh rate has no visible flicker. This is our budget, and it's for the next beta unit. So we're assuming two things. One, that you will be sampling microprocessors and transistors again, since this is for development, and also that you'll need at least 2 more PCB boards in order to ensure that the beta unit is fully functional and doesn't have the same bugs that we encountered. The total cost would be $401.05 and about 30 hours or so for soldering the LED slices. Thank you. Any questions?
How do you go about programming the USB part?
USB part?
That is, what is the strategy for USB communication? Did you use that?
Oh, also there's a demo.
The AV microprocessor already has a big USB?
Yes, the microprocessor that we have comes with USB, which is one of the reasons why we chose it, to simplify our USB work.
Okay. And does it come with canned software, or does it come with enough documentation that you can send the right commands any way you want?
Well, it does come with the documentation on the USB driver that is on the microprocessor, but we also got a development board from Freescale, which came with some example code that we then modified.
Okay.
So what happened here is he turned it on, and this animation was previously stored on it in static mode, meaning it is stored in Flash, and we've set up the state machine such that when you boot up the cube, it will start the animation that is stored in Flash.
You've come a long way.
Don't worry. Any more questions?
There were a lot of iterations of this. Are you happy with the final version?
Are we happy with the final
Or what
version?
would you do differently now?
Designers are never happy with the final.
Okay.
And you're all over budget.
I would say a main thing that needs to be looked into is a way to manufacture the slices. I think we did come up with a very nice design for the slices. You can see all LEDs from any angle, even the worst angle, you can still see most LEDs just fine. But those slices are pretty labor intensive.
Also, because we're using bare wire, it's really easy to mess up with soldering. So this is the best construction that we can come up with, and probably the least time consuming. But again, manufacturing is probably the biggest part of this one.
There are many alternate ways of manufacturing which are all incredibly expensive.
In some souvenir shops, they have those rotating fans with LEDs mounted, so you can display an image using the LEDs there. So I wonder if you can have if you thought about this, using an array of this kind of rotating blades, or maybe oscillating needles to display something like that.
Romain mentioned that, right? Yeah, that was mentioned at one of our IDRs actually, but that doesn't meet our requirements for the project.
Why doesn't it meet?
Oh, because we have to have an 8x8, or well, it originally was 10x10x10. It got reduced to 8x8x8 matrix with LEDs.
Okay, but but you can have that on the rotating blade too.
Yeah.
That would,
The application, as we understand it, our customer wants this to analyze 4-dimensional or time-varying 3-dimensional waveform. So this would actually give us cross-section in 3 dimensions. So having it rotate would set up more of a cylindrical axis, which isn't as convenient as XYZ for digital signal processing. This is Professor Bystrom, our customer, for whom we have made this.
Burden on me. So they're doing what they asked, what they were asked.
I think we can put it on the second floor in one of these cases because there are plenty of pieces of software that will generate the most beautiful screensavers, essentially.
right. And the image files we made very simple. They're simply 512 lines. Each line, just a standard text document. Each line contains a brightness value, and it is in the order left to right, top to bottom, front slice to back slice.
So does this, or do you see this having the ability to scale to something with much higher resolution that can be manufactured in a kind of more consistent way? I mean, this sort of 30 hours or something.
The theory, the concept behind powering and controlling these LEDs is absolutely 100% scalable. Our actual concrete construction methods are not always so. But as we mentioned, the labor-intensive problems would cause a redesign of the actual physical construction.
And could you get the
Probably not. The only reason I'd say that is one of the abilities that you need is to be able to see through the entire cube. So without that aspect, you wouldn't be able to get, so obviously on the face of it, you'd definitely be able to get something as high as that, maybe even higher. But the ability to be able to see through it would be lost. So that's the limiting factor there. Of course, if there was someone to manufacture that, I think we'd be able to.
You guys haven't seen it.
There actually is a project that was part of the motivation for this. I can't remember the company's name, but they have a way to manufacture it, and they have produced a large display. I can't remember the exacts on it.
But I think it's in museum with incredibly expensive organic LEDs, so there's no way we could do anything along those lines.